All right, welcome to Module 7. We are going to be talking all about chassis parts today, steering, suspension, and brake systems. A couple things we're going to go over are shocks and struts, front suspension, rear suspension, steering systems, brake systems, and we're going to talk about how to bleed brakes properly. So we do have a lot to cover today, so we're going to hop right in and get to it. Okay, starting off, shocks and struts. What does a shock absorber do? It keeps the vehicle from bouncing and keeps the rubber on the road, so to speak. A shock uses hydraulic oil forced through small openings to dampen. And you can see right here what I'm talking about. There's small openings right here. This piston's moving up and down, and this is a fluid in here, oil-filled cavity. So it's going to force that fluid through those small openings. So that's how you get a dampening effect in your shock absorber. A strut is simply a shock mounted inside a spring. So that's what consists of a strut, or a McPherson strut. You've probably seen a vehicle with blown out shock absorbers. Going down the road, you can almost see the tire vibrating or bouncing as you're going down the highway. And another one is if you see somebody come to a stop and it looks like they're in a boat, the back of their vehicle or the front of their vehicle just kind of keeps slowly bouncing up and down. That's time to get some shock absorbers. So let's talk about the front suspension. So, starting out here, your wheels connect to the knuckle. Right here is what we call the knuckle or the spindle. Right here we have the lower control arms. They basically act as a hinge. The lower control arms connect to the spindle right here by the use of a ball joint. Here's an example of a ball joint. And finally, the lower control arms are connected by a sway bar. So that bar right there is called the sway bar. When you go over a large bump, this tire comes up. The sway bar is also going to put pressure on this control arm, and it's going to try to force this one up as well. So it just helps kind of link the two wheels together, helps smooth out the ride, and helps with some sway control. Sway bar and links, we just to talk a little bit closer about that. Sway bar prevents body roll when cornering. Sway bar links, it's a pretty common repair. They can become loose or even break. They are not necessarily a safety concern. When they break off, honestly, most people don't even realize it. So right here we have a sway bar link, and then there's also one on this side of the vehicle right here. They get loose, they get noisy, and they break. Again, if you would go ahead and drive your vehicle and take your sway bar links right off, you honestly probably wouldn't even know a difference. So I never tell any of my customers that's a safety concern. When I list off all the problems with their vehicle, by the way, you have a broken sway bar link, it's not a safety concern, so you don't need to fix it now. You want to fix it eventually, but it's nice just to be honest with people about that. Ball joints and control arms. Ball joints are typically pressed into the lower control arm or spindle. Some ball joints are incorporated into the lower control arm and are not replaceable. Right here's an example of that, a non-replaceable ball joint. We always want to check ball joints and control arm bushings during your inspection. I like to put a pry bar on the spindle and work it up and down and look for loose ball joints. Here's an example of a spindle or knuckle with replaceable ball joints. You can see they have been replaced right there. So how do you do that, replace those ball joints? Well, you have to use a special C-clamp tool, and it's going to press the old ball joints out, and it's also going to use it to press the new ball joints in. So let's talk about some different types of front suspension here. A rear-wheel drive vehicle is going to use both an upper and lower control arm. So you can see here, this is an example of a rear-wheel drive vehicle Now we're looking at the front suspension. So you can see the lower control arm and the upper control arm there. This is going to, oh, back up. That's going to allow the wheel to move up and down, and it's going to stay vertical, you know, as it travels up and down by the use of these control arms. And here you can see we have a strut right there. Okay, another type of front suspension is what's called a torsion bar. The torsion bar attaches to the lower control arms, providing lift or providing spring. So how that works, here's a lower control arm, here's an example of one. This right here is the torsion bar. And right here, you can't see, but we'd have like a key, what's called a key, and an adjustment bolt. So how this works is it puts so much twisting force on this rod here. So imagine we had a keyway and we're going to wrap it like this, and we're going to retain it right here. It's putting so much force on that torsion bar that it's forcing this lower control arm down, lifting the vehicle. As you go over bumps, the torsion bar actually flexes a bit and it acts like a spring. So that's always kind of amazing to me how that works and doesn't just break, but they're pretty common. A lot of pickups have them and it works good. Front wheel drive front suspension. Most front wheel drive vehicles use a strut up front instead of a upper control arm. The strut's going to attach right to the body or the frame of the vehicle by means of a strut mount. The strut mount houses a bearing and allows the strut to pivot. Okay, so right here you can see the strut, right here you can see the strut mount, and if you can imagine, this is the body of the vehicle right here. So it bolts to the body of the vehicle. Now as you turn your steering wheel from right to left, this whole strut is actually pivoting. So in turn, this strut mount right here needs a bearing so that it will allow it to pivot. So now that we're talking about that, those bearings can sometimes go bad. So if you ever hop in a car or hear a car where they're turning the steering wheels and you hear kung, kung, kung as you turn the steering wheels, what you're hearing is the spring binding up, putting a whole bunch of pressure on that bearing, and rather than that bearing turning smoothly, it's actually binding and releasing, causing that spring to bind and release, and that's kind of the noise that you hear. So let's talk about replacing struts. Struts typically will last about 100,000 miles, maybe a little bit longer. So when it comes time to replace struts, you can go one of two ways. You can get a ready strut. What a ready strut is when it comes pre-assembled like this. Some manufacturers of struts offer this ready strut. That's typically the best way to go. You just swap it out. You got all new components. You got a brand new spring, and you're done deal, ready to go. When you are not using a ready strut, you have to press the unit apart. It's always a good idea to replace that mount right there, strut mount. The spring, typically the spring can be reused, but we do always like to replace the strut with a new mount when we do it. So when you have to replace a strut, you can't get a ready strut, you're going to have to compress the spring. Springs have a lot of pressure on them. So the best way to do this is with a wall-mounted spring compressor like this right here. Another way to do it is with these little guys right here, spring compressors. If you have to use these bolt-style spring compressors, use extreme caution. Those things are death traps. Pretty scary when you try to use them, and there's just a lot of force there, and if they pop off, you can imagine you got your hands full. You better be ready to jump out of the way. Okay, wheel bearings. A wheel bearing allows a vehicle to roll with very little friction. Wheel bearings are wearable parts. They're also really good money makers. Now, there are two different reasons or two different ways to diagnose a bad wheel bearing. Either by a noise, they get noisy, or they get physically loose. There's a couple different wheel bearings you can expect to see. Let's take a look. The most common bearing that we're going to see is this, a hub style bearing. Hub style bearings come pre-assembled and they bolt right out of the spindle. They sometimes incorporate a wheel speed sensor, which you can see right here, the little wire, that's a wheel speed sensor. Sometimes those sensors are replaceable, sometimes not. So if you have a bad sensor, sometimes you can get a replacement sensor, sometimes they make you buy the whole bearing. The center here where the hole is, the CV axle is going to go through the center and it's going to get retained using a spindle nut. So a tech tip on this, the spindle nut is a very, very important nut to torque. You do never want to tighten this with an impact. That's a number one reason, it's a number one rookie mistake, I guess you'd say, for a technician. This nut right here. So you do a wheel bearing job, you put the nut back on, you take your impact, you tighten it up. You're going to squish the bearing and ruin it. It's going to last maybe a couple weeks, a couple months before it fails again. You have to torque these nuts. It's very important to do that. A rule of thumb that we use at my shop is 180, but I always like to look up the torque spec. It's going to usually be under what's called spindle nut torque. So you're usually going to see that's going to range somewhere between 140 and 210 probably. So if you can't find a torque spec for whatever reason, I always go with 180. Another type of wheel bearing is a press-in style. So the bearing itself is replaceable. The bearing itself must be pressed in and out of the spindle using a shop press. The spindle obviously has to be off the car to do this. And again, torque is very important. So here's a picture of the spindle where the bearing is about to be pressed out of the vehicle. Now when you do that, you first have to press out the hub. A lot of times when you press out the hub, it's going to leave you this little guy right here. That is that ring that you can see right there. It actually stays on the hub. So when that happens, which 99% of the time it does, you got to get that off of there. And there's a pretty easy way to do it. You take your torch and you heat it up one spot. You heat it up really hot until it's just about to start cutting or melting. And then I like to take a little punch. I put this piece in the vise, take a little punch, hammer it right there, hammer it right there, and the thing will walk itself right off. Okay, the next type of wheel bearing, the conventional type bearing, or as I like to call it, the trailer style bearing. So if you look at a trailer, they're always going to have this type of wheel bearing. So the only time we see this is on two-wheel drive vehicles up front, and typically it's on older vehicles that we see this. So it's not real common, but you probably will see it from time to time. One of the differences on this is it's going to require only a small amount of torque. So what I like to do is when I'm doing these bearings, and here's a good note, these bearings can be serviced by repacking with grease. So sometimes as a type of a service we offer for vehicles that have this is we call it a bearing service. We remove the bearings, we repack them with grease, and we reassemble. So these things are actually pretty durable. They last a long time. Sometimes they do fail. So if we have one fail, say we replace the bearings, we replace the bearing races as well. We put everything back together. Okay, you got to put it all back together. Here's your spindle nut. Now on these, they require very little torque. What I like to do is tighten it by hand. Get back. I like to tighten it by hand using my hand on a ratchet, and I put my ratchet right up to the neck, right up to the top of the ratchet versus on the bottom where you can get the most leverage. I don't want much leverage. I want my hand right up by the top, and I twist it with my hand and get it tightened up that way. And you don't want to go too tight on this style because it's going to overheat. So what I like to do is get it snug, actually back it off a little bit because you just seated the bearings, and then kind of snug it up again. So let's talk about rear suspension. We touched on that already, the difference between the independent or the straight axle. So independent suspensions, typically you're going to see that with struts. Non-independent suspension typically uses leaf springs. These guys right here are called leaf springs. So now you can see the big difference. Here's a non-independent suspension going over a bump. So you're actually moving the whole axle when you hit that bump. Versus an independent rear suspension, you go over a bump and just one wheel absorbs the bump versus the whole axle. So that's the benefit, if you will, to an independent rear suspension. Okay, we're going to talk about steering systems now. So there's 4 different styles of steering systems you're going to see. Number 1's a rack and pinion. Number 2 is a gearbox. Both of those systems, number 1 and number 2, are driven by a belt. Use a pump, which is driven by a belt. Another type of system is an electronic. So that hasn't been out for very long. You're going to see that in later model cars. And finally, manual steering. Believe it or not, some vehicles still use manual steering where there's no power steering, mostly on small cars and economy cars. I think the last one I worked on was actually a Kia van, I think something like that. Yeah, manual power steering. Kind of crazy. So here's an example of a rack and pinion type steering system. You're usually going to find this on front wheel drive cars, some SUVs. Pretty simple system, but it can get expensive. So how this works, here is our power steering pump that's going to be bolted to the engine and again driven off of the serpentine belt. It sends pressure, it's got 2 hoses, a pressure and a return. It sends pressure to our steering rack, and the steering rack, here's your steering wheel linkage going into it. The steering rack actually diverts the pressure to one side or the other to aid in steering. It's got valves in there, so as you turn the steering wheel, it actually opens a valve which diverts pressure, actually gives you power steering. The next system we're going to talk about is a gearbox type. Mostly found on trucks or rear-wheel drive cars, and it attaches directly to your steering linkage. So on this one right here, you can see the gearbox is located right there. Your steering linkage is going to come in right there, attached directly to the gearbox, and works the same way as, you got a pressure and a return line, and there's valves inside there. So as you turn the steering wheel, it actually opens or closes the valves in here, allowing the pressure to aid in whatever direction you're turning that steering wheel. Okay, electronic type power steering. Apologize for the fuzzy picture there. This system uses a powerful electric motor to steer the vehicle. There's a few different types, a rack type, a pinion type, and a column type. But basically, yeah, and a very powerful motor is actually turning the wheels for you. So I haven't run into this too much yet, but there are some systems out there that require, some repair. Sometimes the motors have failed, or there's a sensor built into them that have failed. So you probably will run into that in the future more and more often. Manual steering, it's basically the same as a rack and pinion, except there's no pump or no pressure lines going to it. If you open up a rack and pinion, it's just going to be this. This is your pinion gear, this is your rack. So as that turns, you're going to rotate that shaft. It's going to slide that shaft in or slide it out. All right, steering linkage. Your steering linkage is basically what attaches the spindles to the steering wheel. So all these joints, you want to check for slop. And our steering linkage is where we're going to have all of our adjustments for setting toe or for performing a wheel alignment. So on this one, you can see we have an adjustment here and an adjustment here. There's different styles. This is one that you'd see on a Chrysler, maybe a Chrysler pickup or SUV. So Pitman arm is actually, it's going to be what's on this vehicle, what's connected to the power steering gearbox. Okay, so steering and alignment. Grab a drink of water there. So the front and sometimes the rear wheels must have a toe adjustment. It's pretty rare that there's a toe adjustment for the rear, but some vehicles do have it. So what is toe? Toe refers to the angle in which the front tires are pointed, either inward or outward, toe in or toe out, in reference to the center of the vehicle. So when you talk about toe, if we had a perfectly straight line right here, and you set your wheel up to 0% toe, 0 degrees toe, it's going to be perfectly straight and you're going to have no angle at all. If you did that, you're going to have a steering wheel or a vehicle that wants to wander all over the road. And so toe, the reason that vehicles have toe in their steering is that toe is what centers the steering wheel when you let go and helps prevent the steering from wandering. So next time you drive your vehicle, pay attention to that. Going down the road, you turn your steering wheel just slightly to the left and you let go. That steering wheel wants to naturally snap back or center itself again, and that's because of toe. And also, if you had a vehicle with no toe, holding your steering wheel straight in your hand going down the road, it's just going to constantly be kind of wandering. So that's why we put toe in front suspensions or in front steering to help basically the comfort of driving. Caster and camber. Caster is the angle of the spindle in relation to a vertical line, usually not adjustable. So right here, a caster, I always like to, I used to get these two confused. I like to always think of this as like a caster on like a rolling cart. So caster is basically the amount of, you can see on this one, the amount of angle that the front spindle has. So if there's a sharp angle, you're going to have more caster. If it's up and down, if it's basically straight up and down vertical, you can have less caster. Again, usually, I mean, that's one of the readings you'll see in an alignment machine, but typically it's not even adjustable, so I don't really worry about it too much. Camber refers to the tires leaning toward the inside or outside of the vehicle in relation to the vertical line. So on this one, you can see this vehicle has some pretty negative camber. You can see the tires leaning that way. So on a lot of vehicles, I'd say in about kind of split. About 50% of the vehicles, there is a camber adjustment. 50% there's not. And when there is, why you need to adjust camber is, if you're doing suspension work and you have everything loose and you put it back together, you want that tire to wear normally. You can see this tire here is not going to be wearing normally. You're going to be wearing out the inside of the tread faster than the outside of the tread. So this vehicle here, you would want to adjust the camber to get that tire running nice and flat. Another thing you're going to notice is that every vehicle you drive, if you turn the steering wheel all the way to the left, so you're in a parking lot, you're doing a really sharp turn, that the wheels are actually made to develop some camber as you turn. So you turn the wheels all the way to the left. If you looked at the vehicle, your wheels are actually going to lean to the left a little bit too. Same when you go to the right. Go all the way to the right, your wheels actually lean a little bit to the right. So that's just something to think about. Sometimes if you look at a vehicle, the wheels cranked all the way off, you're like, whoa, what's up with that tire leaning like that? It's designed to. Okay, brake systems. So, brake systems on a vehicle, you're going to use hydraulic pressure to apply friction to rotating parts, causing the vehicle to slow down. Brakes are, shops count on brakes for being a pretty good money maker. Every shop you're going to work at most likely is going to do brake jobs. So let's look at how this works, starting with the driver pressing on the brake pedal. You can see this is a typical brake system here. Let's take a closer look. Okay, here's our brake pedal. The brake pedal connects to the brake booster using a push rod. Your brake pedal switch is also going to be located here. So there's going to be right there you can see a little switch. So that's going to be turn on the brake lights when you step on it. Also, the transmission needs to see a signal from that brake switch. The brake booster is always mounted on the firewall. It's going to give you the assistance that you need to have power brakes. So how that works is it actually works by vacuum, by using engine vacuum. You can see right here's our vacuum hose, our vacuum feed to the brake booster. So how that works is by putting engine vacuum to the brake booster, it actually uses a big diaphragm inside to help, basically, to help apply pressure to the master cylinder. So without that, without power brakes, you really have to press on the brake pedal hard. So that's a pretty cool invention. The master cylinder always bolts to the brake booster. The reservoir is going to sit on top of the master cylinder. So you can see right here is our brake fluid reservoir. This right here is our master cylinder. Okay, some reservoirs have a brake level switch, brake fluid level switch right there to indicate when the fluid's too low. The master cylinder works like basically it's got same as the clutch master and slave system, but has a large piston inside that forces hydraulic pressure into the brake lines. So as you press on the brake, there's a big piston here that strokes. So the harder you push on the brake, the more pressure or fluid is going to be sending through these lines. Brake lines run from the master to the ABS housing. If, assuming your vehicle has ABS, which most of them do, right there, that's kind of what an ABS housing looks like. Okay, from there the brake lines run to the wheels. Brake lines hold an extreme amount of pressure, so when you work on brake lines, make sure you repair them properly. And no compression fittings. No compression fittings. No compression fittings. Illegal. Okay, from the ABS unit, the brake lines run directly to the wheels. At the wheels, you're now using that hydraulic pressure to either squeeze brake pads against a brake rotor or to force brake shoes against a drum. So the difference there is disc brakes or drum brakes. Let's take a look. Okay, let's talk about disc brakes. Disc brakes are by far the most common type of brake on later model vehicles. On early model vehicles, drum brakes were more common. Disc brakes can be used on the front or the rear, and they use a squeezing motion to create friction. So the two pads get squeezed together. Brake rotors. Rotors can wear in two different ways, either by warping or by simply being worn thin. A warped brake rotor will feel like a pulsation when stepping on the brake. So one of the things I always feel for on a test drive is when I slowly apply the brakes to see if there's any pulsation. Here's a little tech tip to diagnose whether the front or rear brakes are warped. So say you're on a test drive, you step on the brakes, and if you can feel a pretty good pulsation happen, let go of the steering wheel. If the steering wheel shakes, the front rotors are warped. If the steering wheel does not shake while you're feeling that pulsation, it's likely in the rear. The rear rotors are warped. Brake rotors can either be turned or replaced when need be. To be honest with you guys, I don't even have a brake lathe in my shop. We don't even turn rotors because most of the time, if you get a brake rotor that's either warped or has, it's rusted out or it's just been worn thin, the cost of brake rotors today on newer vehicles is they're really cheap. I mean, you can get a brake rotor on most vehicles for 30-40 bucks per rotor. So for that, it really doesn't pay to turn rotors, in my opinion, because you're turning a rotor, you're making them thinner, so it's smoothing them out. But in my opinion, it's better just to replace them, especially because if you turn rotors, you're going to be charging somebody $10 to $15 per rotor anyways. For if you can replace a rotor for 30 bucks, in my opinion, that's the best option. So brake calipers. Brake calipers bolt directly onto the spindle or rear axle using a caliper bracket. They use a piston inside to press the pads together. So right here you can see the caliper bracket, and right here you can see the big giant piston. So as you step on the brakes, here's your brake line, you're putting pressure behind this piston. The piston's gonna squeeze these brake pads against the rotor, and your vehicle is going to stop. Okay, so when we're servicing brakes or doing a brake job, always clean and lube the slide pins in the caliper. So when you have a caliper where it attaches to the bracket, it needs to slide back and forth. So this one uses some pins right here. You always want to clean and lube those. Tech tip, what I like to use is actually use anti-seize on those pins to lube them. There are some other lubes. I think there's even a brake slide lubricant you can buy, but I've had great luck using anti-seize. Okay, some rear brake calipers incorporate the emergency brake into it. You can see that right there, that little bracket. So when you pull on the e-brake cable, it actually squeezes the brake pads together. We're going to talk a little bit more about that. Some more about brake calipers. When replacing brake pads, the caliper piston has to be driven back inside in order to give enough room to put the new brake pads on. So you're doing a brake job, you need to drive these pistons. You're replacing old worn out brake pads, so that means these pistons are extended further than they need to be to accept new pads. So you put your new brake pads in, it's not going to fit. So you need to drive these pistons back into their housing there, back into their cylinders. So you can either use a C-clamp like this or something like this. This is a special tool designed to drive those pistons back in. So on this, it looks like the guy grabbed an old brake pad. So that's a real good way to do it. This is a dual piston caliper. He's going to screw that together, and it's going to push those pistons right back into their housing. One thing, tech tip that I think I have noted somewhere else, but when you're doing that, always make sure your reservoir cap is off, because otherwise you're going to be building pressure on top of that cap. It's going to fight you a lot harder. So take the reservoir cap off. Rear calipers. Rear calipers that have an e-brake integrated into them, they need the piston to be rotated while compressing it. It's a screw type. So rather than grabbing your C-clamp or your special tool and just driving that piston in, when you have a rear brake caliper that has an emergency brake built into it, it needs to get screwed in as it's being compressed. So he's going to screw in clockwise. Okay, so a couple last things about calipers. One thing I wanted to mention to you guys, so if you suspect a faulty caliper, if you're not sure, example, the pistons can seize inside the calipers, or the slides won't free up, maybe you're doing a brake job and you go to compress the piston and it's like, geez, that one went in a lot harder than the other one, just replace it. They're not that expensive and you don't want to come back. Okay, so yeah, I was just going to take a minute also to kind of mention you guys. So for any repair you're doing on a vehicle, you know, try to keep people's best interests in mind, but also from experience, I've learned this, don't try too hard to save people money. If you try to make something work and you try to piece something together, you know, a lot of times it comes back to bite you. I mean, as sad as it is to say, it seems like every time I try to do something to save somebody money, it comes back to screw me. So, you know, do what you would do if it were your parents' vehicle or your grandparents' vehicle, or, you know, something like that, or a family member that you'd be like, listen, let's not screw around with this caliper, just replace it, you know, or tell people, if it were my vehicle, this is what I would do. And again, somebody's going to be a little upset if you quoted them $200 for a brake job. You said, listen, it's going to need this caliper, but that person's going to be a lot more upset if they go down the road and they have a brake lockup and now they got to come back, make another appointment, make arrangements. So don't try too hard to save people money. I just wanted to kind of get that out there. And a tech tip about brake calipers is if you suspect a caliper of hanging up or dragging, one thing I like to do is grab my infrared temp gun, go drive it around the block, and then measure your brake rotors. If you see one brake that's higher than the rest, that's a good indication that you got a caliper dragging. So brake pads. So there's lots of different styles. Brake pads come in ceramic, metal, etc. I always tend to go with the OE material when you're shopping for brake pads. Some brake pads use a metal tab called a squealer tab to indicate when the brakes are getting thin. On this one you can see right there. So as your brake pads get thin, when they get really thin, it's actually the brake rotor is actually going to start touching that tab right there, and it's going to cause a horrible squealing sound when you step on your brakes, and that's designed to get people to come in. Yeah, my brakes sound terrible. That's just indicating you got low pads. So cheap brake pads, if you're doing a brake job for somebody and they want the, you got, say you got an option 3 different pads for this. Okay, for example, you got a Chevy Venture comes in and you say, okay, we can do a brake job. I got 3 different choice of pads for you. Personally, myself, I don't even give the people the option to put the cheaper pads on unless it's somebody who's, just needs the thing drivable again, who doesn't really care about anything. Because cheap brake pads, typically they make more noise, they'll squeal, and they let off more dust. They don't last long. You get what you pay for, that type of thing. Brake pads can last anywhere from 25,000 to 40,000 miles, typically, depending on your driving style. So anyways, let's talk about drum brakes. Drum brakes are an older design, but they are still used on vehicles today. You're always going to see these in the rear. So drum brakes work a little bit differently than disc brakes. They use an opening force to spread the brake shoes against the brake drums, creating friction. Most drum brakes are self-adjusting. Drum brakes last a long time. You can easily get 100,000 miles out of a set of drum brakes. For that reason, whenever I replace drum brakes, I recommend replacing everything. Everything meaning the brake shoes, the brake drums, the wheel cylinders, and the hardware kit. So, and another thing I wanted to mention to you guys, do not remove brake drums just to inspect them. Oh, there we are. Do not remove brake drums for a routine inspection. If you have to, be really careful. The reason for that is as these drum brakes wear, they create a ridge on the inside of the brake drum. And so you try to slide the brake drum off and it's going to get caught on that ridge. Next thing you know, you're pounding, prying, trying to get the drum off, and you end up breaking some of the hardware inside there. And so I always tell people, let's not even touch those rear brakes until one of 2 things. Either they start making noise and grinding back there, or you do it just on a timed interval. Be like, yep, I got 110,000 miles on this vehicle now. Let's just get the rear brake done, job done. So let's take a look at the different components to a rear brake drum. Okay, brake drum. Brake drums can either wear out by being thin, or they can actually get warped and feel like a warped rotor. Brake drums also can be turned, but again, guys, I just replace them rather than screwing around or trying around to turn them. Just replace them. Brake shoes. Brake shoes can wear out. Now again, there's no great indication when they're about to wear out. There's no squealer pads on these. Basically, they start grinding when they're worn out, when it gets metal on metal. Or, like we talked about, you can advise the customer to just plan on having them replaced soon after reaching 100,000 miles, the 100,000 mile mark. Also, once in a while we see brake shoes can delaminate, causing noises, smoking, binding. What that means is the friction material right there is glued onto this metal bracket. So from time to time, we see that glue let loose, and this friction piece actually falls off and gets wedged, between the brake drum and between this bracket. And then that's when we get smoking, noises, binding. So whenever I do have a drum brake open, I always make sure, if I'm not replacing them, make sure that everything's still bonded nicely if they're not starting to separate. So when you're replacing rear brake shoes, always check the shoe thickness, because on some of them, not all of them, but on some of them, they have a thicker and a thinner shoe. And the thicker shoe is always going to be on the prevailing side, or the side that's going to take the most amount of load when you're slowing a vehicle down. Okay, wheel cylinders. Wheel cylinder uses opposing pistons to spread apart the brake shoes. So there's a piston here, there's a piston here, and as fluid comes in, the pistons are forced apart. They can leak brake fluid when they fail. So whenever we have the brake drum off for whatever reason, I look real closely right here, and sometimes you'll see they'll be wet, leaking brake fluid. And just once again, guys, whenever I do a rear drum brake job, I replace all this stuff, including the wheel cylinders, all at once, because what are the chances that this wheel cylinder is going to hold up for another 100,000 miles if you don't do it now? Pretty slim. Hardware kit. Basically, the hardware kit in there is just the springs and retainers holding everything together. Okay. Here kind of shows you a drum brake that's put together, a diagram. So here we have our wheel cylinder forcing the two brake shoes apart, and you can see all the hardware in there. You can see right here is our adjuster. So this is kind of a, they don't show it on here, but picture a little gear with teeth on it. So as the brake shoe opens and closes, this right here is the adjustment cable, comes up here and it goes up to there. I'm going to start over there. As your drum brake is applied, it's going to stretch. So imagine the drum brakes are spreading apart right here. It's going to stretch this cable, and it's going to move this little hinge, and it's actually going to move this adjuster. So as the brakes wear, it's going to give another click, and it's actually going to tighten up. So picture this is like a bolt. As you unthread it, it gets, the length actually gets longer and longer. So that's how that works. A few more things about drum brakes. Whenever you're doing a drum brake job, make your rough adjustments before reassembling. Don't just throw it together and be like, oh, the thing's got a self-adjuster, so it'll eventually self-adjust. It'll take a long time for that thing to self-adjust, if you're way off. So what I like to do is get your adjuster. I keep tightening it until the brake drum doesn't want to go on anymore. Then I back it off a little bit. Then I know it's close. When it comes to drum brakes and you have a vehicle that has a low brake pedal feeling, so that means you step on the pedal and it feels like the pedal's going way down, almost all the way to the floor before it stops and before it starts, giving resistance or pressure. That's typically caused by unadjusted rear brakes. So whenever we find this, you can adjust the rear brakes. Usually the brake adjusters have froze up, or they're just simply not working correctly. They've rusted up, whatever. So you got a low brake pedal and you got a vehicle with drum brakes, pop the drums off, do a brake adjustment, pedal comes way up. Okay, now drum brakes also incorporate the e-brake. If we go back to our diagram here, right here, the little metal silver bracket right here is actually e-brake. You can't see it, but imagine that there's a big cable running to it right here on the back side. As you apply that cable, it's going to stretch it out, and it's going to cause the brake shoes to spread out and apply. Okay. So we're going to talk about brake fluid here. Brake fluid is nothing more than a type of hydraulic fluid. It always has kind of a nutty smell, and it's really slippery. Brake fluid has to always be sealed, even in the containers. When you guys are done using your brake fluid bottle, put the cap back on. because brake fluid has a tendency to wick moisture from the air. It absorbs moisture, and moisture will contaminate brake fluid. It makes it turn really brown, and it'll even cause it to gel up in some cases. So brake fade is a term that's used. Brake fade, what that is if you ever heard somebody say, yeah, I'm trying to think here how to explain that. Sometimes like if you're really beating on your vehicle and you're really slamming on your brakes, like imagine you're racing around a racetrack, all of a sudden your brakes start to work worse and worse. That's called brake fade. And what that is when your brake fluid becomes so hot, it actually starts to boil. And now you're losing pressure. That fluid's starting to boil. It's actually starting to create air, and air compresses. Fluid does not compress. So brake fade, you just lose brakes. So here's kind of a myth of the industry, or maybe it's kind of just a gimmick that Quick Lubes use to get more business. But brake fluid, in my opinion, doesn't need to be regularly serviced or changed. The Quick Lubes will always try to sell you on this. Here's the deal. Unless you see brake fluid that looks very brown or really, really, really dark, I don't ever try to sell my customers this, because honestly, I feel like it's an unnecessary service. You go to the Quick Lubes, to get your oil change, and that's one of the things they always try to push is, look at, this is what new brake fluid looks like. This is what your brake fluid looks like. It's a little bit darker. Don't worry about it. That's just something that in my mind is just taking advantage of your customer when it really doesn't need to be done. So, okay, bleeding brakes. So we're going to whip through this, but there is a process when it comes to bleeding brakes. And what I refer to with bleeding brakes is this. Whoops. Whenever you open up a brake system or the hydraulic system, you will need to bleed the brakes to get all the air out of the system. Okay, so our very first step to bleeding brakes, say we're going to, now let me back up once. If you replace just a caliper, you can bleed just that caliper and be fine. If you replace an entire brake line, or for whatever reason, if the system's been run out of brake fluid, now you got to bleed the whole system. So we're going to talk about bleeding the whole system, all four wheels. So your very first step is go around the vehicle, get all the brake bleeders to come loose, and then tighten them a little bit. You just want them to get them to come loose. Once in a while, you have to grab the torch, heat them up a little bit. If they break, guess what? You got to replace the caliper now. So that's your first step. Get all the bleeders to break loose. Okay, so we're going to start bleeding. You always want to start with the wheel furthest away from the master cylinder. So typically that's going to be your passenger rear wheel. Have a helper or grab somebody else to help you. Getting ahead of myself here. Next step, make sure you have the brake reservoir full. Do not let it go empty during the bleeding process, because otherwise you're sucking air. You're not gaining anywhere. Otherwise you're sucking air and you're defeating the purpose. Okay, get a helper. Have the helper get in the vehicle and start pumping the brake pedal for you. Ask him to pump the brakes. Now, with all your bleeders closed, make sure all the bleeders are closed. Ask him to start pumping the brakes. After three or four pumps of the brake pedal, ask him to hold it down. So while the brake pedal is being held down, now you're going to loosen the bleeder for 2 to 3 seconds. It's going to shoot out a bunch of fluid, and it's also going to shoot out a bunch of air. Tighten the bleeder and repeat until no more air seems to be coming out. So again, he's pumping the pedal. The way we do it in our shop, the driver or the person's up there pumping the pedal. The guy actually by the wheels doing the brake bleeding. He's the quarterback calling the shots. So I get a helper up there, and I say, okay, go ahead and pump it up. He starts pumping 3 or 4 pumps, and I say, okay, hold it. He holds the brake pedal. I crack the bleeder open, spits out some fluid. I close the bleeder and I tell him, okay, go ahead, pump it up again. And I do that until there seems to be no more air coming out and just strictly fluid. Then go to the next furthest away wheel. So say I did the passenger rear, now I'm going to go do the driver's side rear and repeat the process. Once all four corners have been bled, tighten all your bleeders one last time. Just go over them one last time, make sure they're tight, and then ask your helper to hold pressure on the pedal. Now go around every fitting that you have touched during your repair and just check for leaks. Leak check the whole system. If there are no leaks, you're all done. Go test drive it. Here's a tech tip. Sometimes bleeding brakes can be kind of problematic. Sometimes it takes a long time for the fluid to actually get to the wheel. So the way to speed up that process is by gravity bleeding. Gravity bleeding is a process where we have the reservoir full. Say we replaced a brake line. Say we replaced a brake line on a Chevy pickup. It's a long brake line from the front to the rear. So I'm going to fill up the reservoir. I'm going to go to the rear, and I'm going to open both rear bleeders and walk away. And eventually, maybe it's going to take 10, 15 minutes. Eventually, you're going to start noticing the brake fluid dripping out of the bleeders. So gravity has just brought that fluid all the way there for you. So it's going to save a lot of pumping and bleeding to do that. So then you tighten up the bleeders and you're ready to bleed. So that's called gravity bleeding. Tech tip. If the brakes are still spongy after you're done bleeding it, that means you got air in the system. See if there's an automated bleed process in the scanner, then repeat the bleed procedure. So on some vehicles, there's an automated bleed, and basically what that does is it cycles your ABS pump. Cycles the pump, and sometimes air gets trapped in the ABS unit in the ABS pump, so it cycles the pump and opens and closes all the valves to get any air purged out of that system. After you did that automated bleed, guess what? You got to bleed it again to get the air now through the lines and back out the bleeders. So, you do that, you'll be in good shape. Okay, wow, we made it through. That was a lot of information to cover. We did it, but that was easy. That wasn't so bad. So our next module is one of the most exciting ones that we're going to have. Electrical. I am super excited to teach electrical to you guys. I got some really unique ways to teach it, I feel like. So get ready for that one, and hopefully you guys will grasp electrical and learn to love it like I did. So good job. We made it through the longest module probably, and we will see you next time. Thanks.